Yep. Okay, you can sign on. I'm here. Okay. Let's say a prayer. Father, Son, Holy Spirit. Just pray for the world in general. We pray. You know what? I know what we need to pray for. We need to pray for basically loosening up the supply chain. We've got definitely supply chain problems coming down the line. So we pray that everything clears up for Christmas and beyond. We pray, Hail Mary, full of grace, the Lord is with thee. Blessed art thou amongst women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now at the hour of our death. Amen. How are we all doing?
Good.
Okay. I'm going to take quick attendance. While I'm taking attendance, just go through all this. It's on the notes. You want to just switch to another tab. Look at the notes. Just read what I wrote on position. I'll add this. Some of you may have. Some of you may be questioning what's the difference between position and displacement. It's basically the same thing, with a slight difference. So I'll make a note of that. So position is displacement. You can think of it as the same thing, starting at the origin. Your initial position with position is starting at the origin. So what does that mean? I'll just visually show you what the difference is. The origin on a number line. When I always speak of origin, I'm thinking in my mind of a number line, which is numbered. To the right, it's positive. To the left, it's negative numbers. So I'm going to focus on the positive numbers. This would be, I'm going to add a little bit more here, 4, 5. Okay, so this would be your, let's say you started at the origin, you walked to here, your position would be 3. You walked all the way to 3. Your position with 3. It's measured from the origin, always. Now, with displacement, you can start anywhere. You could start at 0, in which case it would also be the position. You could start at 1. This could be your initial. This would still be your final. Your displacement in that case would be your distance from initial to final, which is just 3 in that case. Okay, so displacement can have any initial position, any initial spot on the number line. When I talk about position, you're always starting here, always starting at 0, moving either to the right or left. Okay, now on another tab, just pull up the notes from last day, and just go over what I spoke about as far as a position time graph. And then I'll set up here. I'm going to go over page 47 as well. But just as a prelude, go over those notes while I'm setting up. Exactly. I'll go over page 47. Give you another minute, and then I'll start here. Okay, so I'll go over page 47 so you can bring that up. That's in another tab. I think I posted it. Yeah, I posted it. Back on October 25th. Just pull that up in a separate tab. I'm going over number 5 through 7. Okay, so let's look at number 5. You can read it to yourself, and then I'll highlight some of the key points. Before we start with number 5, no, I always like making a list up. So it's a constant speed. Notice it says it travels, key phrase and word is constant. That's important. You have to know the context under which you apply a formula. That means you can apply this equation. We went over this. This is the equation for how far. You see the phrase how far? That's asking you for the magnitude of the displacement. As long as you don't turn around, which you're not, the magnitude of the displacement and distance is the same. So how far is distance, but same thing as the displacement as far as magnitude. I'm going to use this equation because I know you go back to the notes, I can use this under the constraint of constant speed or velocity. Speed or velocity. Velocity is just speed with a direction. So I know I can use that equation. Now, before I begin, let's just highlight a couple of things. Notice this speed is in seconds. So I want my time. This is important. I want my units to be complementary. If that's meters, that's got to be meters per second. That's got to be seconds. You can't mix kilometers per hour and seconds and meters. You have to stick with whatever units is consistent throughout. If it did mention kilometers to begin with, then I'd have kilometers for the displacement, kilometers per hour for the velocity, hours for the time. So it's one of those two sets of units, either the red or the purple. Can't mix the purple and the red. Okay, so just a couple of notes here so we're clear on how we're going to do these calculations. They give us different times. The times are different, so I have to do a calculation for each. But I'm given the time. I want to calculate how far. Okay. So for the times that I'm given, let's make a little preliminary note down here. We have 1 hour. I mentioned this to you before. 1 hour is 60 times 60. 60 seconds per minute, 60 minutes per hour. So that's 3,600 seconds. I need everything in seconds. I'm just going to give you a list before we begin. That's my first time. 1 second, that's easy. Milliseconds. You need to be familiar with, these are called prefixes. Milli. Milli stands for 10 to the minus 3. So this becomes 1 times 10 to the minus 3 seconds. Drop the milli and replace it with 10 to the minus 3. I'm going down the whole list first so we know what to use before we begin. This is called micro. That little, it's a Greek letter. It represents micro in this case. What does it mean? That stands for 10 to the minus 6. So we drop the micro, that little prefix there, and we put 10 to the minus 6. Last one is nano, little n. To memorize it, you have to know what it stands for. Represents 10 to the minus 9. Just know it. And you can look it up if you're not sure, but I would know it. It comes up so often. So this one you're already familiar with. This one you should already know. Milli means 10 to the minus 3. What is 10 to the minus 3? 1 1,000th. 1 divided by 1,000. This is new. Micro. 10 to the minus 6. What's that? 1 over a million. When you make your first million. With the way inflation's going, you're going to make a million probably. So 10 to the 6 means 6 zeros. 1 followed by 6 zeros. 1 over a million. It's minus. That means you take the 1 divided by the 10 to the 6. 1 over a million. The nano, the n, stands for 10 to the minus 9. What is that? 1 over a billion. 10 to the 9 means 1 followed by 9 zeros. So these are really small. This is small. This is very small. This is extremely small. 1 over a billion. Very short time periods. So expect short distances. Okay, now we can calculate the distance with this equation. I'm going to bring it down here. I'm going to keep consistent with the units. Notice I brought the units with it. Meters for displacement. Meters per second for velocity. And seconds for time. I'm going to put a little, just as a reminder, put a little half arrow above there. These are vectors. In this problem, it doesn't make a difference, but later on, we need to get the direction right. That's a reminder to include a positive or negative. Okay, so just plug in The speed is constant 10. I'm going to include units this time. Later on, I'm not going to include units until the very final answer. But I'll include units so you can see how it cancels out. The time for the first time is 1 hour, which we said is 3,600 seconds. Seconds will cancel out. We expect a unit of meters. That's what we get, what you're left with. I'll put it in red, meters. The seconds cancel out like a number. Okay? And then you get 3,600 by 10, 36,000. Put it in scientific notation. Move the decimal 1, 2, 3, 4 places to the left. So it's positive. Okay. Next, 1 minute. That's easy. Same equation. Try not to lean over. That's what's preventing my back from healing faster. Because normally I write on the board, right? So I'm upright, but I'm leaning over. So if my printing gets a little messy, that's why I'm trying to lean back here. Okay. So 1 minute, 10 meters per second. And 1 minute, which is 60 seconds. Seconds again cancels out, giving us what we expect. Meters. And 60 times 10 is 600. If it's a number 100 or bigger, put it in scientific notation. I'm not worried about positive or negative at this point because the question was how far, which means just give an absolute value. Okay, next is 1 second. Usually we don't do this many calculations with different times, so I'm just copying the formula out. I'm going to skip, now that you know what happens to the unit, I'm not going to include the unit till the end. You can do that. It's up to you. You can cancel units out, but you have to have at least a unit in the end. That has to be included because it's a measurement. So 1 second, that's okay, I'll include the unit one more time. Seconds cancels out. 10 meters. That's enough. You don't have to put it in scientific notation. It's less than 100. Okay, millisecond. So notice what I'm doing. The way I'm setting this, yes, I need to see equations. You can't just plug in numbers. I can follow it, but it makes it difficult to mark. So start with an equation, because then that, at least if you make a mistake after that, you get partial marks for the equation. So it's 10 meters per second. Milliseconds, so it's 10 to the minus 3. You can plug that into your calculator. 10 times 10 to the minus 3, just 10 to the minus 2. You can write 1 times 10 to the minus 2 if you want. Seconds cancels out. Meters. Okay, so notice the distance is getting less and less because the time is decreasing. Okay, for this next one. Micro. 10 to the minus 6 seconds. Why did I convert it? Why did I convert the micro to 10 to the minus 6? Because that leaves me with seconds, which I can cancel out instead of microseconds. I can't cancel out microseconds. That's the whole point of me replacing the prefix with a proper exponent. So this, when you multiply it out with your calculator, is 10 to the minus 5. Yes, you can put a 1 in front if you want. And then nano, last one. Nano is 10 to the minus 9. So now I can calculate or cancel out the seconds. Can't cancel out nanoseconds, but I can cancel out seconds, leaving you with meters. So this works out to be 10 to the minus 8. Okay. Number 6, just read that to yourself, please. I like that triangle. Okay, so that's the equation you'll be given on a formula sheet. The reason why I'm doing this again for you is so you know how to derive it. You need to know how to derive, in this case, the time. So the question is, how many seconds? Well, how did I know with this it was this particular equation? Well, we're told, first of all, that it's traveling with a constant velocity. 36. Okay, so make a list of what you got. We're told that it travels, we're given the distance, which is the same as the displacement. And then the expression that they use is how many seconds? That's your time. You'll see this. You're looking for expressions that stand out. How long usually implies time. How far, I just went over that previously, is displacement. How many seconds is obvious. That implies obviously time. Okay, I don't know, question mark. So that's your list. Make a list. Yeah, sure. The list will tell you the formula. The formula will contain all the variables in the list. They have to match up. Also, this is constant. Constant means this equation can be used. Remember, that is the equation for constant velocity. So it all fits. Okay, now I have to solve for the time. You already know how to do it, but I'll just remind you. Cross multiply, you get this. That's your equation for displacement. And then divide out the velocity. Both sides. That's it. Okay. So I can now just take my displacement, which is 1620. Divide it by the velocity, 36. What is that? It's about 40. 45, okay. It should work out to be seconds. If you're not sure, this is meters on top divided by on the bottom meters per second. And that works out. Just double check here. Meters divided by meters per second. Remember, when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. Just flip it. Seconds on top, meters on the bottom. Cancels out, leaving you with what you want, seconds. Okay, so this works out to be 45. Limited by this, so 3 sig figs. I'm not going to be overly particular. If you want to just stick with an answer in general to 2 or 3, I'll get a little more particular later on, but for now, 2 or 3 sig figs for the final answer is fine. Okay, B, that was A. You got 36 meters per second. What's the conversion factor? What do you multiply by to convert to meters per second? 3.6. Memorize it. Okay, so that's 130. 1.3 times 10 to the 2 kilometers per hour. So when you're going from, this is a smaller unit. This is the bigger unit. Kilometers is bigger. So if you're going from smaller to bigger, multiply by this. Okay, read over 7. Okay, look what I did. I just read it, and you started at 1 and you ended at 3:30. That's 2.5 hours. That's your time. Make a list. It says it's moving at constant velocity of 94. If you're not sure whether that's a velocity or not, sometimes it doesn't say, look at the unit. That's the giveaway. It's kilometers per hour, velocity. Where will it be after 2.5 hours? Where is question of displacement? Where? How far? Question mark. So your equation has to contain all 3. It's easy at this point. We've only got 1 equation, but later on we'll have, it'll mount up to about 10 or 12. So it's this equation that we've been working with. Rearrange for displacement. Okay, we're going to use this. Now keep in mind, before we start, this is important. In this particular problem, I'm going to have to break that down. What does that mean? Triangle D is your displacement. What is displacement? Its final position. That means whenever you see a triangle, it means final. Just wait 1 second before you write it down. Final minus initial of what? Of whatever comes after. final position minus initial position. Yeah. Does it start with an initial position? Well, let's read it. It says, traveling at constant velocity towards the west. It's already 17 kilometers west of the school. And it's going to continue to travel west. Okay? So let's make sure the initial position here we already have. This is 17 kilometers, and it's west. Now, I could put negative here. This would have to be negative as well. You want to do it that way, you can. But because you're going in the same direction, you're not changing, you're not going back towards the east. I would just keep it as a positive, but just at the end, remember that this is west, so in fact, it is negative. But we'll simplify it. We'll just keep everything as positive. It works. So going back to this, you can rewrite it as d final minus 17. We'll skip the units. Yeah. Yeah. Is equal to 94 times the 2.5. I'm just plugging all the values in. I didn't plug the units in. They cancel out. We're going to get the right units of kilometers. So you get a df is equal to 94 times 2.5. You're going to add 17 to both sides. And that should give you your right value of 252 kilometers. Now, everything, remember I said everything is moving to the west. You have to include west. Or you can put a negative or both. Insert it at the end if they're not changing direction. It could get a little messy. I didn't want to do this to confuse you, but what you can, if you want to do it strictly correctly, you put it's west, and west is going to be negative. That would be a negative there. You put a negative there. It all works out. You'd end up with a negative answer. But that overcomplicates it. In general, if it's going in the same direction, just remember what direction it is in the end. Make sure you put it in the end. It works. Keep everything positive that way. When you can't do that is when it gets overly complicated, when the thing goes west and then it turns around to the east. Then you have to keep track. Okay. West is negative. Let's make a note. West, when you're writing down a number, you want to be strict about it, it's negative. At the very least, you have to indicate that direction in the final answer. Negative, west, or both. East is positive. Okay, now I'm going to go on to more about position time graphs. So let's go back to this just so we can review. I know I told you to read it. So it so happens, this is an interesting point. On a position time graph, the slope of a straight line happens to be the velocity. The slope of a position time graph is the velocity. So I'll make a note of that just to remind you. Just continuing on with those notes. Slope of a position or D versus T graph equals the velocity of the object. How fast it's moving. I'm going to make a copy of that graph. Slope of the position time graph equals the velocity. There it is again. Can I shrink it a little bit? Yeah. Okay, notice something before we left last day. I wrote this. Notice this. Is this slope changing for the line? No, it's a constant. Notice I used the word constant. So a line on a position time graph isn't just a velocity. It's a particular type of velocity. It's a constant velocity. So the slope of a straight line, and this is in the context of this type of graph. It's a position time graph. The slope of a straight line on that type of graph has to be a position time graph, is a constant velocity. Underline constant, because the slope is a constant. What's the unit of that velocity? Well, it's usually meters per second. You just take the unit here, divide it by the unit here. Usually it's meters and seconds. Okay? As opposed to what? As opposed to instead of, I'm going to copy this again. This helps me out. Does that work? No. I don't know if I can copy this out. Same graph, except now I'm going to change it slightly. I'm going to it's still a position time graph. Oops. I'm going to change it so it looks like this. Instead of a straight line, it's going to be a curve in places. There are places where the slope is constant. This looks pretty constant here, but there's other places where it's not, where it's a curve. So if it's not constant, it's not a straight line, it's not constant. Any of those curved sections means it's not a constant velocity. So it represents, if it's not constant, that means it's changing. So this graph represents changing velocity. Not the same at every point, it's not constant. So it doesn't make sense to talk about a constant velocity in most of these positions here. I'm going to label certain positions. So this is position A. This is, let's say, position B. This is position C. You could talk about the velocity between 2 points in time. You can say, what's the, let's say A and B correspond to, I'm making these numbers up, but let's say 2 and 5 seconds. What you would say is the velocity between 2 and 5 seconds. Well, it's not constant. You can see by this curve here, not constant. It's not a straight line. So how do we go about calculating that? We can actually find what's called the average. What's the average? The average is the slope of that green line, the line that connects the 2 points. So let's write that down. The average, and it's always going to be 2 points in time. the average velocity, yeah, is between 2 points in time, in this case 2 and 5 seconds. Okay, you'd calculate it the same way as you would the constant velocity. You need 2 points. You need a point A, you need a point B. The average is between 2 points and equals the slope of the line that joins those 2 points, the green line in this case. And which you already know how to do. Once you draw a line, between points A and B, you know how to calculate the slope. We've done that. Right? You'd find the rise. I'll enlarge this. You'd find the rise and divide that by the run. Same as you do for a straight line. Except now you're connecting 2 points. So you can only speak of an average because it's not a constant anymore. It's a changing velocity. So you can speak of an average between the 2 points. Is there another average velocity here that you could calculate? Sure, you could choose, instead of A and B, you could choose A and C. So you always need 2 points. Just calculate the rise of a run. Same as you did before. That's the average. Okay. I'll copy this out again. Erase some things in it. I need to use this graph again, but for a different purpose. Keep the 3 points there. I'm going to speak of something else. There's a third type. There's a constant velocity. There's an average velocity, which you need 2 points for. And there's also an instantaneous velocity, which ties in to something that you're more used to. And that's the velocity that you measure on your speedometer. So it's this, and as far as magnitude, it's stated on your speedometer. The magnitude is when you're driving. Leaning over again. So it does have, this has more of a physical meaning. You could be speeding up onto the highway. In that case, it would look like this section of the graph here if you were speeding up onto the highway. That represents speeding up on the highway. In which case, if you were to look at your speedometer, you would see it, the needle would be, if it's a needle speedometer, it would be increasing. If it's a digital, you see the number increasing. You are not moving at a constant velocity, indicated by the curve. So, how do we go about measuring that? We're interested in actually measuring that actually from the graph itself. You do, in this case, the following. You draw a line, you zero in on the point, and you draw a line that's just touching the point, parallel to the curve, only at that point, as close as possible. Then you extend the line. extend the line. Then what do? Then you calculate the slope. You need to find you can choose any point you want on that. This is called a tangent line. You need to know this if you're going to go on and take calculus. Tangent line. And what do you do with that tangent line? You need, same thing as before. Calculate the rise. Choose any 2 points you want. Calculate the rise. And calculate the run. So we'll get a little bit more practice. What would the tangent of this be? Let's take a look at point A. Zero in. 1 second here. Tangent's always at 1 point. So we want to make a note of that. Make a note of that. The instantaneous velocity is the velocity at 1 point in time. I want to underline 1. It's not 2 points. Unlike average, it's 1 point. You only need 1 point, either point B or point A or point C, but not 2. At 1 point in time. Okay? We're going to label this VINST, standing for instantaneous velocity. The VINST equals the slope of the tangent. Where? At that 1 point. That's the hard part. How do you draw the tangent? You know how to calculate a slope given a line. How do you draw the tangent? I can only give you examples. There is actually a way of doing it properly, but the quick explanation is all we need. Zero in on the point. Let's look at point A. Extend the curve. There's a white part of the curve here. Extend it with a little line that's parallel to it as much as possible. Do the same here. Extend it only a short distance, because after obviously that curves off, it's no longer easy to find what's parallel to it. And then extend it further into a straight line. This is by no means going to be accurate. It's going to be off. I take that into account. Find the slope. Find the rise divided by the run. Okay. Let's look at point C. This is an easy one, actually. Extend the tangent. I would zero in. You can see here that the curve here, right close to the red point, can be extended slightly so that it's parallel to the curve. Extend it further. Whoa. Do the same thing on the left. Extend it further. Now this is by no means perfect, but you can look at this and see that the slope is close to zero. What does that mean? At that moment, your instantaneous velocity is zero. Okay. Just a couple more examples. This is not a tangent. Here's your point. I'll label it A. This is not, it will not cut it. It's not going to cut the curve. It will just touch the curve at that point. Just graze it. That's a tangent. Now, is that parallel to the curve as you get close to that point? Hard to tell. Going to be a very inaccurate drawing. I take that into account. Now, can you get a more, if you knew the mathematical expression of this curve, could you figure out the exact value of the slope of the tangent? Yeah, that's calculus. We'll learn that later. But at least you got an idea of how you get to it. What you're doing, I don't want to get to it. It's too confusing. So, three main calculations. Instantaneous, just draw a line at a single point and find the slope of that line. That's instantaneous. Average, this is average here. You need 2 points. Draw a line that connects those 2 points, find the slope. That's your average velocity. Why do we speak of average and instantaneous on a curve? Because it's not a straight line. It's not a constant. The first one that I introduced is this here. This is the easy case. It's a straight line. It's a constant slope. So it's a constant velocity. That's the easiest case. Couple more things to add here. This is a position time graph. Below the origin is negative numbers. This is negative. Obviously, this is positive. Negative numbers in the physical world is indicated by west. So this would be east. Actually, what do I want to do? There, that one. It's my A. I'll letter these in a second. So this is a position time graph, D versus T. One more. Maybe a third one here. And make sure you draw those slopes correctly. So I'll label them. This is A, B, C, D, E. On a position, what we want to do is express three characteristics when we describe when we're describing these constant velocities. So for A, I'm going to obviously write that it's constant. It's a constant velocity indicated by a straight line. The person is moving with a constant velocity. Okay, that's the first characteristic. Characteristic one. Okay, constant or not? Well, it's a straight line. It's constant. If it were a curve, you would just say not constant. Changing. Second characteristic. In no particular order, how fast are they moving compared to the others? It's a relative question. So in A, is he moving the yellow line? How is that slope compared to the slope of B or C? You think A is moving faster than B or slower than B? Yeah, it's a greater slope. So I would say you have to express either fast. Here, let me do this properly. Slow, medium, or fast. You have to express one of those three. This is obviously fast compared to the others. It's all relative. So you'd say it's a fast velocity. That's the second characteristic. Slow, fast, medium. Third characteristic, are they moving towards the east or are they moving towards the west? Is it a positive? If it's a positive slope, they're moving towards the east. So are they moving in A, B, in this case for A, is it moving towards the east or west? East. It's positive, so it's moving towards the east. Include both. If you gave this on a test, that's fine. Either one on a test would do, but to get used to it when you're doing your homework, include both. Okay, the fourth characteristic I am not as particular about. I'm only going to ask you when it comes to a quiz or test for those first three, but the fourth is helpful as well. What's the starting position? Well, I'm going to have to add numbers here. So let's say this is 5 meters, this is 6. And here, this is going to be -7. So and in some of these questions that you're going to get next, they do ask you for the starting position. So A, you start at about 6 meters, whatever the unit is, plus 6 meters. Or you would say 6 meters, alternatively 6 meters to the east. Okay. I'm, again, more particular about the first three. Fourth one's not expected on a test, but let's finish this. B, how would you express it? Is it constant? Yeah, it's constant. Straight line. 2, how would you say the person's moving? Let's say it's a person that's walking. How is he or she moving with respect to A or C? Medium, slow? Yeah, it's somewhere in between medium. It's a medium slope. 3, it's got a positive or negative slope. Positive. So put both. Another way of saying that the person's moving towards the east. And starting position is the same, 6. C, I'm going to quicken this up. Everything, just copy it. Everything, everything the same except for the second characteristic. What changes? Yeah, the purple line indicates a lesser slope. So you would indicate that with slow. D, starting, I would change with D, starts at a different position. That's what stands out. Obviously, it's constant. I would say relative, it's a negative slope, but it's relatively fast. I would say a medium to fast. You can put medium. It's very subjective, but medium, I'd accept that. Medium or fast. Doesn't matter what order you write these characteristics. What's the difference now as far as the direction? Now you're moving towards the west. It's got a negative slope. Another way of saying that is west. Put both, just so it's clear to me you understand. And then fourth, starting position is a little bit 5 meters. You got to be, yeah, we got to be particular. East. These would all be east. East. East of the origin. or plus if you want, as opposed to minus. E, last one. We're almost done. Go back to this. E, look at that. That's a quickie. You don't have to write much. That's a quick one. What's the slope of that? What does it look like to you? Make a judgment call. It's horizontal line. 0. Slope is 0. What's the velocity if the slope is 0? 0. At rest. Same thing. You could put either. Velocity 0. You need to know that they're the same thing. It's at rest. He's not moving. What's his position? Position is -7, I think, right? 7, -7, or you can just put west. 7 meters west, or -7, or both. Okay. Do I need to talk about medium? No, I don't, because he's not moving. That's sufficient for, I don't have to talk about constant velocity. He's not moving. That's it. If it's a 0 slope, just say at rest and give the position if it's a homework assignment. Okay, now I posted, go to Google Classroom, I posted this handout. You can read page 52. Read page 52 and then do page 53. 9 to 11. Just 9 to 11. That's it. What time is it? Ah, crap. Okay, you can start on that. I would read, when you're reading, listen, when you're reading page 52, read it carefully. See if they got the math right. Check it out. They did, but you check it. Make sure they use the right points when they calculated the slope. But just breeze through it. Check the points out. You're going to be sore in the morning. Retest for the formula rearrangement part of the test is Tuesday and Wednesday next week. You had to attend the tutorial. I'm limiting it to when I went over that. I also, that's what I want to tell you. I need your test as well. So when you come to do the retest, bring your old test, and then I can just mark it, and then I can make the change right away. I have to see your old test to do that. Does that make sense today? You getting the slopes and all that?